I think it's now time to continue to the first presentation. And the first presentation will be by Thomas or Tom Timberlake from the University of Bristol. And he will discuss the effects of seasonal resource gaps on bumblebees.
I'm gonna talk to you today about the effect of seasonal resource gaps on bumblebees. So I'm just going to start with a brief bit of background about floral resources, so what they are and why they're so important to pollinators. So pollen and nectar, which are collectively known as floral resources, are the primary food source for most adult pollinators. And in the case of bees, they're larvae as well. So pollen and nectar are made up of a whole cocktail of different ingredients, which collectively provide bees and other pollinators with all of the energy and nutrients they need to grow, to forage and move around, to mate and to produce new bees. So they have a key role in structuring pollinator populations. And it's no surprise then that floral resource declines, which we've seen across many parts of the world, are a primary driver of pollinator decline. And just to give you some idea of the scale of these declines, a study led by our group a few years ago showed that nectar resources in the UK have fallen by about 30% since the end of the Second World War. So this is largely a result of widespread agricultural intensification, the expansion of fields, the clearance of many semi-natural habitats such as hedgerows, and the general kind of tidying up of the landscape. So this is translated into a huge reduction in the overall amount of food available to pollinators on the landscape. And so, of course, there's been a lot of concern about this, and there have been various efforts to reverse some of these declines, most notably the agri-environment schemes, which incentivize farmers to plant up areas of wildflowers, things like flowering margins, and restore flowering semi-natural habitats, such as hedgerows and hay meadows. And these have been very successful in many ways. So, as you can see, overall nectar resources have increased over time. But there are many reasons why this problem is not yet solved. So first of all, we still haven't returned to anywhere near historical nectar levels. And the diversity of sources where this nectar is coming from remains lower than it was. But there's another very important and I think often overlooked factor why floral resources are still a problem for pollinators, and that is the timing of when these resources are available through the year. So the phenology of floral resources. And I'm just going to explain now what I mean by the phenology of floral resources. So first of all, phenology in its broadest sense is the timing of ecological events. So this is the timing of when different stages in the life cycle of an organism occur through the year. And more specifically, flowering phenology is the timing of when a plant flowers in the year. So this species here shown here is flowering in the midsummer, but every different species, particularly in a temperate environment, will have a distinct period in which it flowers. This may be early, it may be late, it may flower for a very short period of time, produce lots of flowers, or it may provide fewer flowers over a longer period of time. So there's lots of different variations on the way in which the phenology of each individual plant species. And when we sum all of these together at the community level, this gives us a kind of seasonal pattern of floral resources at the landscape level. And this is what is relevant to most pollinators, particularly generalist pollinators like bumblebees. This represents their kind of overall stock of food through the year. And I'm just going to explain why this is potentially so important for bumblebees. So in this scenario here, which is just a schematic diagram, we have the bulk of floral resources being produced in the midsummer. So this is when most species of plant tend to be in flower. And there's far less available in the kind of spring and the late summer. Now, although most pollinator populations do tend to peak in the midsummer as well, including many bumblebee species, we know that bumblebees are active, and there are very important stages in the life cycle of a bumblebee that occur outside of that midsummer period. So this simple phenology diagram here shows the different stages in the life cycle of a bumblebee colony, of a typical colony. And you can see that although the colony is at its peak size in the midsummer, where most workers are out. There are very, very important life cycle events that occur outside of this. So, for example, queens that may emerge as early as February in the year, in the early spring, and they need to forage and build up resources in order to establish their colonies and develop their colonies. And likewise, in the later period of the year, the later summer, large numbers of new queens and males are produced, and these must mate, and then the queens must forage before hibernation so that they have enough resources to see them through the winter. So you can imagine that in a theoretical sense in which bumblebee and resource demands peak in the midsummer when workers are out, but there are still demands from the colony outside of this peak summer period. So they need to have resources available at every point in their life cycle. And so if there was a point at which supply of resources on the landscape was not meeting this demand, this would create resource gaps where the supply was not meeting demand, and this could impose bottlenecks on the populations and limit their populations. And from a conservation point of view, this is important to understand, because if we want to design initiatives to support bumblebees or other pollinators, we need to know when we need to support them the most. So, for example, in this scenario, if we planted species which flowered in the midsummer, as most plant species tend to, we may not actually be doing any benefit for the bumblebee population, because the time at which they need them is not in that midsummer period, it's outside of that period. And so this is the concept behind my PhD and what I'm going to talk to you about today. And there were four main kind of questions I wanted to address on this topic. So first of all, where are these gaps that we suspect there might be in the supply of resources through the year? And if we do see these gaps, do they overlap with periods when bumblebees actually require those resources? Thirdly, is there any evidence that these gaps are affecting real populations of wild bumblebees? And finally, of course, how do we actually go about filling these gaps? So first of all, this question about where the gaps are. So to investigate this, I worked on 4 farms across the west of England and recorded floral abundance at very high resolution throughout the flowering season, from kind of late February right through until November. So this was kind of a weekly resolution, and we combined this data set with an existing data set from our group on the nectar production of individual plant species, so that we could work out how much nectar each plant species was producing at each point in time and work out its resource phenology. And so this gave us something like this. This is the most common species we found on our farms, and in 2 separate years. And you can see that each plant species has its distinct period in which it is flowering, its distinct phenology. And when we sum all of these species together at the landscape level, we get this very seasonal pattern of resource availability. So this is nectar availability through the year, measured as sugar. And you can see it's a very, very seasonal pattern. So there's a large peak in the spring and the summer, but a notable gap in between called the June gap, which has been talked about before, but it's quite starkly present in this data. And you can see how truncated the year's supply of nectar is. So there was very little nectar available before May and after July. And we know that bumblebees are active outside of these periods, of course. And interestingly, this supply of nectar was very dominated by just a few plant species. So 3 plant species made up about 50%, over 50% of all of this nectar supply. And these 8 species here, shown in order of their flowering times, collectively made up about 90% of all nectar supply, which in itself might be a cause for concern, given what we know about the importance of a diverse diet for bumblebees. But anyway, getting back to our questions, so we can see that there is this very seasonal pattern of resource availability on these farms through the year. But does this actually matter? Because is it out of synchrony with bumblebee demand? So we wanted to investigate this, and we did this by scaling total nectar availability at each point in the year by the estimated abundance of the three most common bumblebee species on farmland, Bombus terrestris, lapidarius, and poscorum. And this gave us a measure of the amount of sugar available per individual bee at each time point in the year. And we could then overlay the kind of estimated daily sugar requirements of an individual bumblebee. And this is data from Rotheray et al. 2017. And this immediately shows us this mismatch between supply and demand, and these quite stark gaps in the very early spring and the late summer. So this gap in the early season is a period when queens are emerging from hibernation and have very high energy demands. They need to forage and establish colonies. But we know that farmland nectar resources are extremely low at this time. And the other gap in the late summer was actually a far larger gap. And this is a period when bumblebee populations are still pretty large. There's lots of workers around and lots of new queens and males produced. But farmland nectar has already started decreasing substantially for the year. And so supply was not meeting demand. So the question then is, we can see that these gaps are there and that they might be an issue for bumblebees, but do we actually see any real evidence of this in bumblebee populations? So to investigate this, we worked on 12 farms across the west of England again, and we wanted to find out which of these 4 periods of resource availability through the year, the early spring, summer, and late summer, was having the greatest influence on bumblebee populations. So these different periods of the year correspond to the periods we identified as the main phases of variability in floral resource phenology. So on each of these farms, we classified habitat composition, recorded the area of lots of different habitat types, and we also measured nectar resources in each of those 4 periods of the year. We estimated colony density using a molecular method, using microsatellite markers. And what you can see is there's a great deal of variation in colony density between farms. And what we wanted to investigate is what was driving this variation. Which of these factors on the right were having an influence on this variation? And what we found is that the supply of nectar in September, in that late summer gap, was a really, really important predictor of bumblebee colony density. It explained over half of the variation in colony density between the farms. We didn't find any of the semi-natural habitats to have any influence on colony density, but interestingly, the proportion of gardens did have a significant effect. And this was even though gardens were present at a very, very small area on the farmland. So together, these 2 factors explained well over 60% of the variation that we saw in colony density between the farms. So clearly, very important factors. And I just want to unpick these 2 different factors now individually. So first of all, the gardens. So we know that from previous work that gardens are very important in supporting bumblebees on farmland. So they provide valuable nesting resources. They also have a very rich and diverse supply of floral resources. But there's something more specific about their floral resources that might also be very important, and that's the timing of them, the phenology. So in contrast to the very seasonal supply of nectar availability that we see on farmland, gardens actually have a very relatively consistent supply of nectar through the year. So gardeners tend to try and plant things that ensure there's always something flowering through the year and looking beautiful. And what this means is that it creates a nice smooth pattern of nectar availability through the year, which may be buffering bumblebee populations by buffering out that seasonal pattern of resources on farmland. And we see some evidence for this in some work I did during my PhD on pollen metabarcoding, where we collected samples of bumblebees, of a range of different bumblebee species, at 3 points through the year, in the spring, the summer, and the late summer, and used metabarcoding to identify all of the pollen grains present on their bodies. And we then classified the different plant species that were present on them. And what we found is that they were using a significantly higher proportion of garden plants in the early and the late periods of the year than in the midsummer. And this is despite the fact that garden floral resources do peak still in the midsummer. So there was something going on here, and it does tend to imply that that bumblebees may be using gardens as a kind of lifeline to support themselves when farmland floral resources are very low. And so this is something we're still working on, but is a kind of interesting first signal. So going back to this, the late summer resource gap that was also very important in limiting colony density. So what seems to be going on here is that this very low availability of nectar resources in the late summer period is coinciding with a very important stage in the colony life cycle of bumblebees, when new queens are produced and need to forage and build up reserves before going into hibernation. And so it seems to be that those limited resources are potentially limiting the quality in which those queens go into hibernation and reducing their survival over the winter, and therefore reducing the colony establishment and colony density the following year. So this just seems to be what's occurring, and it's quite an interesting pattern where we're seeing floral resources in one year impacting colony density on the following year. And so what we want to know from a management point of view is, how do we change the shape of that curve to boost nectar resources in the late summer and therefore theoretically boost colony density the following year? And so this brings me on to the final question in this presentation, which is how we go about filling these gaps. And although there were these two important gaps in both the early spring and the late summer, I'm going to focus on just the late summer gap for now, because it's the one we found evidence of actually impacting bumblebee populations. So what we did to investigate this was we ran a simple modeling exercise using data on our 12 farms on the nectar resources produced by different habitat types. And what we did is we applied a virtual manipulation to these different farms. So things like changing the area of semi-natural habitat types, planting cover crops, applying different environmental stewardship scheme options. And each of these would change the supply of resources in September by a certain amount. And this would move each farm, which is a red dot, up the regression plane to some degree, and therefore increase colony density. And so we could measure the resulting change in colony density of these different manipulations. So I won't go into each result in detail, but just to kind of pull out some highlights from this. So what we found, interestingly, was that increasing the area of semi-natural habitats on farmland actually had a very limited effect on the bumblebee populations. And this was because the supply of resources in these habitats in late summer was already so low that changing their area actually didn't have much effect overall. But increasing their quality by promoting late flowering species did have much more of an effect and substantially increased colony density. We found that environmental stewardship scheme flowering margins, the pollen and nectar mixes, were effective at increasing late summer nectar resources and colony density, but were far more effective if mown early and in multiple phases to extend flowering later into September, to delay that phase of flowering. We found that various cover crops can add very valuable late season floral resources, so particularly red clover, which often flowers into September. This could provide a huge amount of nectar in that late period of the year. And in fact, adding just a hectare of red clover to a kilometre squared of farmland was enough to actually completely fill that late summer gap that we showed. We also modeled a few scenarios of habitat degradation and loss to see how that would affect bumblebee populations. And we found that losing hedgerows had the greatest effect on bumblebee populations, because this is the most important habitat for providing resources in the late summer. We also found that thistles and ivy were extremely important in that late summer, and losing these was predicted to have a very negative effect on bumblebee populations. So I'm just going to finish now with some kind of conclusions and take-home messages. So hopefully some of this work has shown that the timing of nectar supply might be just as important in some cases as total nectar availability in limiting bumblebee populations. So it's not just about how much you have available to you in terms of resources, but also when those resources are available and whether they're available at times which are useful to you as a bumblebee. We've seen these resource gaps present on farmland in the west of England, and although this study was limited to this region, I think it's fair to say that resource gaps are likely to be a feature of most simplified human-altered landscapes such as farmland, which have lost a lot of their diversity and heterogeneity, and therefore have a far more boom and bust supply of resources provided by fewer species, rather than a more continuous supply on more diversified or natural landscapes. And so given this, species which flower during these resource gaps, such as in our case, the early spring and the late summer, should be prioritized in pollinator conservation schemes to try and plug those gaps and smooth out the supply of resources through the year. And as a kind of general point, I think considering phenology in any agri-environment scheme or conservation scheme that aims to support bumblebees or other pollinators or any seasonal consumers in a landscape will increase the success of those schemes. So I'm just going to end there with a big thanks to all of my research group and all the fantastic field assistants and farmers who gave me permission, and my funding body, NERC. And sorry about the technical hitch, but hopefully I didn't overrun too much.
Okay, thank you for this nice and very clear presentation. There are several questions asked, and I will pick one. One of the questions is by Jacob Visser from the University of Antwerp, and his question is if competition with other pollinators has been taken into account when you calculated the resource availability.
Yeah, so it's a good point, and we only focused on the 3 most common bumblebee species on these landscapes because they were the only ones that we had enough data for to quantify their kind of energy requirements. But we didn't take into account any of the other pollinators that will be competing for that nectar supply. So the nectar supply we mentioned represents the entire supply at a landscape level, which is shared out between all the pollinators. And we were only looking at the demand from bumblebees. So it's definitely true that the actual availability to them will be lower than what we found, even lower, because there will be other pollinators that are competing for that nectar. So it was kind of what we found was the minimum. That was the maximum available to them, but in reality, it will be even less than what we found.
Okay, thank you. And I've also one question. So what we see, at least in the Netherlands, and I think it's also the same in the UK, is that the rare species retracting are mostly retracting to wide open areas where you have very few flowers in spring and autumn, and a very abundant peak during summertime. So how does that correspond with your work?
Yeah, I mean, I don't know. It doesn't immediately make sense why that would be, unless their phenology is such that they have far higher demands in that time. The other thing is it's often the most important resources, particularly in the early summer, in the early spring, are not necessarily what you normally expect, like the flowering meadows. They're things like shrubs like willows, which are often present in very scrubby, kind of quite sparse landscapes. And willows can be a very, very important resource in that early season. So it could be that perhaps these landscapes don't look flowery, but they do actually have things flowering outside of that peak season. But otherwise, I don't know, I'm afraid. I don't know why that might be.
Yeah, one of the things I was wondering if it can be that in these areas, the early species or the common species cannot reproduce during spring. So there's no competition of common species of bumblebees in these areas. But
yes, I mean that's an interesting thought, because obviously Bombus terrestris is a pretty early species and often tends to dominate. But I know what you do see in the UK is there's been a disproportionate decline in late emerging bumblebee species, and are the ones that will therefore have the highest kind of reliance upon that late summer period. And so this kind of corresponds to what we've been finding, that late summer resource gap does seem to be really, really important, and those later emerging bumblebees are disproportionately struggling, because that late summer period is kind of, that's when a lot of those traditional hay meadows used to flower, but the transition away from hay towards silage production means you've kind of cut out a lot of that late summer resource availability on farmland. So I think that's potentially why these late season species are struggling. But perhaps less competition from the early species would help.
Okay, thank you. I think we have to continue with the next presentation. So thank you again for your presentation.